Good evening, everyone. First of all, thank you so much for tuning in. Well, this talk is about something that I've always wanted in production. That's the ability to scale well in advance before that one spike hits in prod. Together, let's explore how to combine KEDA and Prophet in order to make Kubernetes autoscaling predictive instead of reactive. Well, I'm Snigdha Kanchana. I'm right now working as Cloud Site Reliability Engineer at IBM Cloud. Well, if there's something all SREs here or DevOps engineers here might relate to, most of the time we think about performance, scaling, and stability, right? So this is one idea that I've been exploring, using predictive models to drive smarter solutions when it comes to Kubernetes autoscaling. Let's talk about the problem. Here's a typical scenario in Kubernetes environments. If you see the graph, the red line here represents the actual CPU usage. We see a sudden spike, right? And the gray dashed line here, that shows the allocated CPU, which scales up shortly after the spike. This is how reactive autoscaling works today, and of course, that's a reliable baseline, and this has been serving multiple use cases for each one of us here. But in environments with predictable traffic patterns, what if we have an opportunity? Like what if we could anticipate the load well in advance? That's what opens the doors to predictive autoscaling. Let's talk about the solution. Here's how it works. We collect the historical metrics, forecast the future load with Prophet, and then let KEDA scale based on it. All of this isn't a black box. Let me tell you, it's totally Kubernetes native and so easy to integrate. If you see the graph here, this black line shows the actual CPU usage over time. Also, the red line here, that's a forecast line, which is generated 15 minutes ahead. And the gray dash line, gray line that represents the CPU allocation decisions, which is now made by the Kubernetes cluster itself, which follows the forecast line closely. All of this is a major shift from the traditional HPA behavior. Now, let's meet the brains and the muzzle of predictive autoscaling. KEDA, all of you might have been aware, this stands for Kubernetes Event-Driven Autoscaler. And what makes KEDA unique is the fact that it lets you scale your workloads based on external metrics, not just the CPU and the memory. It comes with 60 plus built-in scalers, right from Kafka, Prometheus, Redis, and CloudWatch. And more importantly, this is cloud agnostic. Whether you are on EKS, GKE, OpenShift, or either running Kubernetes on a bare metal, this works the same. But in our use case, KEDA is the component that reads predictions from the Prophet and uses them to scale your pods. Now, let's meet the forecasting brain of the system. That's Prophet. It's an open source time series forecasting model that's built by Meta. And why Prophet? The answer is because we want to know what's the load that's going to be in next 10 to 15 minutes, right? And let me tell you, it's lightweight, Python-friendly library that fits naturally into Kubernetes pipelines as well as Kubernetes ecosystem. Now, let's talk about the architecture. On the left, we start with Prometheus or any metrics backend, collecting time series data like CPU, QPS, or any custom workload metrics. This data is then pulled by Prophet Forecast Job, a lightweight Python service running as cron job or a deployment. It fetches historical metrics from Prometheus and uses Prophet model to predict the future demand, say 15 minutes ahead. Now, those forecasted values are then published via a forecast adapter. Now, here's where KEDA comes in. We configure a scaled object with an external scaler that reads all these forecasted values. And then KEDA feeds this data to HPA, which adjusts the replica counts proactively. And finally, all of this scales your target workload, like an API server or a background job. And let's talk code. On the left, we have a Python script that runs as a scheduled job. It queries the Prometheus for historical metrics and applies the Prophet time series model. And on the right, we configure a scaled object in KEDA to use that forecast as a trigger for autoscaling. And this forecast will serve via a lightweight adapter that's as an external metric again, which KEDA can scrape periodically. On this note, I wanted to talk about few important parameters. That's threshold, which defines when scaling is actually triggered. And another important one is polling interval. This tells KEDA, how frequently to check the metric source, and then the cooling period. This sets a wait time before scaling, and it's of course needed to help stabilize the workloads, right? And in the traditional setup, we rely entirely on Kubernetes HPA, which is purely reactive. Now with KEDA and Prophet, we flip this around. I hope we have unlocked a new dimension of autoscaling in Kubernetes now. And appreciate you all taking time today. And it's always wonderful to be part of the community, that's constantly pushing what's possible with Kubernetes and the cloud native. Thank you all so much.